Okay, now it is record. Okay, the CAD software is just a translator that allow us to perform or to draw lines, curve, shapes, and many others. And in the market right now, what we have out there is there are a lot of CAD software. Some of those is more like similar, but basically each of it was developed to perform a certain task. For example, like AutoCAD, for example, right? AutoCAD or Autodesk, it is more it was developed to entertain users who are designing building, okay, building, including the civil engineer and also some of the architect. Okay, unlike CATIA, SolidWorks, UG, it is more towards part design. Okay, part design. You design certain part and then you can perform assembly drawing. Okay, to develop a certain product. And then also we also have Fluent, but Fluent is ANSYS Fluent. Fluent is, yeah, you can draw something, but at the end of the day, that particular software is meant for fluid flow analysis, similar to Abacus. Abacus is you can draw something and you can save that particular file as a 3D model, but then the purpose of developing that particular software is for the structure analysis. Okay, and there are a lot more. When I graduate last time, of course in UPM, I'm using CATIA, and when I did my final year project, I'm exposed to SolidWorks. When enter the manufacturing company, I would say, of course we do R&D and we design something. At that time, that particular company using what they call it UGNX, and Rhino, if not mistaken. There is purposely to do a rendering so that the images can be better. Okay. Okay, this is some of the history of computer design. CAD started way back in 1957. Back then, we are still trying our best to get the independent, right? 1957. None of us exist at that particular time, for sure. And then it was called Pronto, and then continued by Sketchpad in 1960s, then CATIA. Between these, there are a lot more actually, but I'm just focusing on the most prominent or popular. Okay, then CATIA, AutoCAD, SolidWorks, and so on. Actually, CATIA and SolidWorks, they are on the same under the same roof. Okay. Okay. When you design something, if you can recall, when you do part design using CATIA, the thing is, when you finish up your product, your parts, you can save in a many type or various type of format. Okay, there are PRT, that is the common format for CATIA, CAD for the CATIA, and then for SolidWorks they use it .SLDPRT, and for AutoCAD or Autodesk they prefer .DWG, and DWG is only, if I'm not mistaken, .DWG is for the 2D images or drawing, okay, not for 3D. Okay, and also there are file what we call .stl. Okay, .stl. I can't remember what is S, what is T, what is L, but that particular file is very useful because you have to save your part design with that particular format .stl, so that you can transfer that file into the slicer software. Slicer software is the software that generate the G code for the 3D printer. Okay, and it is a common parts that may appear in your life as an engineer. Okay, then this is not a single part actually. There are some joining part here. Okay, and why I put this picture is because these particular parts, if you look here, normally being produced using a machine where you have a chunk of or a block of metal or aluminium, for example. Okay, then you cut using certain machine. You cut one section after another. Then finally, you will end up with the this particular object, the physical object. Unlike the 3D printer, what happened is you do the reverse. You are not starting with a block of object. You start with a layer by layer. Okay, you adding material. This one you subtract the material. Okay, you cut. Cut means you subtract the material. You remove material. But 3D printer you add a bit. Okay, layer by layer basically.
It's like CNC machine, doc.
CNC machine.
Subtract.
Yes, yes. You remove material, you cut the material. There is a
Okay, right.
leftover, right?
Yes.
I'm not saying a 3D printer does. You can eliminate you didn't have any leftover, but the 3D printer also will have some amount of leftover. I will talk that part later. What was it? Okay. Okay. This is Autodesk Simulation Multiphysics. SolidWorks also have a function something like this, and then CATIA also have. If you purchase the full version, you can get this one. I think in our faculty we have 1 or 2 license. Last time I'm not sure whether they renew that particular license or not, because it is very, very expensive. We are talking about 100,000 per license, if not mistaken, if for the full version. Okay, and as I mentioned earlier, that the software that available out there is designed for a certain purpose. Okay, we start with the AutoCAD. Yeah, right now, okay, last time AutoCAD, you can only do a 2D drawing. Okay, until 2000, I think around 2005, they start to work on the 3D version for AutoCAD. Okay, before that, it's just a 2D, because I learned when I was in UPM early 2000. We have also AutoCAD. The version is R14, if I'm not mistaken, and that one is only 2D. And what happened is there is no icon, beautiful icon like this. You see, here it is very user friendly. Last time you have to bring a piece of paper, and on that particular paper there is a shortcut key. Okay, for those who are familiar with games, okay, cheat code or whatever you call it, um, you have to press like Control L for to create a line, Control X if not mistaken to erase or something like that. Okay. Of course, the usual one like Control C and Control P is still the same. Okay, for copy and paste. Control C, Control P is still there. Okay, and um, if the point here is, if you want to purchase or to buy a certain software, make sure that what you are going to do with it. If you are looking for something related to fluid flow, then go for ANSYS Fluent or Star CCM or Phoenix. Okay, there is uh, the software that was developed purposely for that method. And if you are just looking into the CAD to do design, okay, if you want to design a certain parts, okay, like a mouse that has a lot of curve, right? So I would say either SolidWorks or CATIA can do the job. Of course, CATIA is much better, but for beginners, I think you have to start with SolidWorks. CATIA, if you want to design a surfacing, to do the surfacing, you need a lot of practice as well as understanding on what you can do and you can't do. Okay, and it is a typical drawing that being approved by a certain company. Okay, the parts just look like this, but when you look into the detail of it, and then you start scratching your head. Okay, what is going on here? Okay, but anyway, this part is produced by machine process, because when I look at this particular symbol down here, okay, this symbol 1.6 here, this symbol represent a surfacing where there is a machine that cut. Okay, this particular part here is placed horizontally, then there is a machine will cut like that. Okay, and moving on, not moving on, moving back actually. This is a traditional tools that we, I'm not sure whether you have experience on it or not, but it is a really painful work when I was in a high school, because I was in the scholar technique, and we learn engineering drawing when I was Form 4 and Form 5. Okay. And then when I enter university, of course, you have to take another course. Okay, anyway. And this is the assembly drawing. Okay, before I move on, I would like to remind you guys, if you want to do design, okay, please, if you want to design a certain product, make sure you design each of the single part, okay, draw each of it, even the screw, washer, bolt and nut, etc. Then do the assembly drawing. Assembly drawing is like this. Okay. Only then, after you have completed, you are happy with it, you have performed the kinematics or to see the motion, to see whether the joint is perfect according to what you need. Okay. And then you can start uh, making or produce each single part. Okay, don't produce the parts without do the assembly drawing, because what happen is there are two things. One is the part will not match or it will not fit with this design, and the other thing is the most severe is you unable to do the assembly because some of the screw you can't reach that particular location. It is, you know, the position of the screw is behind a certain object, so you can't reach that point. So make sure you do the assembly drawing, then you know how to perform the assembly physically, only then produce the parts, either through machining process or through 3D printing or whatever process that you might prefer. Okay, and it is the SolidWorks, and it is AutoCAD, the newer the newer version of AutoCAD. Yes, you can produce a 3D parts, but I did try using AutoCAD to produce. Even on my computer here, I think I have AutoCAD. Okay, it is pre-installed when I bought this particular computer. I'm not sure whether it is genuine or not, but it is on my computer here. And I would say it is close enough. It is just behind in terms of the user friendly, just behind SolidWorks, I would say. Okay. Last time the 3D um, capability of AutoCAD is worse. Okay, it's worse, but now it's getting a lot better. Okay, the advantages of having a computer aided design. Of course, it is an advanced drafting tool where you don't need any uh, um, what do you call that, T-square or BOFA set, mechanical pencil, and etc. to do the job. And you can visualize your product. You can you know, navigate, or you can look in many angles on the product that you have produced. And then it will help you to improve the data organization instead of put everything on a piece of big drawing like A3 size or A2 size or even A1 size. You can save it in as a digital data, and you can transfer much easier and quicker through your internet and other communication devices. And also, if you can save it as .stl, for example, you can send it to the 3D printer to do the printing for the physical part. And if you save as a certain type of format, it depends on what you are going to do and what the software is. You can do the post-processing, for example, to do the computational fluid dynamics or structural analysis or heat uh, heat transfer and so on. Okay.
Prof, I have a question.
Yes.
Our old method, which is we used to draw in engineering drawing using
Yes.
the T-square and everything, is that obsolete? We no longer produce such sketches?
For me, to be honest, if you are teaching a student, for example, I'm more convenient to start with the traditional method first, because the reason is, you know, when you do design the
So we see the top view, side view.
yes, when you have a certain object, okay,
Yes.
let's say a car, for example, okay, without the basic knowledge of multi-view, or then you will have problems. How to start, where to start.
Yes.
Okay, you can't really know to draw the, because when you want to produce this product using CATIA, for example, you start with a plane, right? Either front or top
Yes.
or side, left side, right side, and so on. So if you don't have that visualization, knowledge, then I would say it's quite hard. It's not impossible, but it is a hard process.
Yeah.
Okay?
Okay.
But if you have a basic, then should be no problem. So
Right.
when I teach a student, like last semester, engineering drawing, the first 4 weeks, we use a traditional method, just using a A4 size of paper, then you use the ruler and many other stuff lah, to get the mind to be set towards to know the projection. Okay.
Okay.
Okay. Thank you. Okay. This one. This is the projection, where for engineer we use the parallel projection, but for the architect they much prefer to use the perspective projection. Okay. Engineer on the left, architect on the right. That is a general representation. Okay, this is line of sight. Okay, and then we have orthographic view. I think you have learned on this last time when you took that particular subject. Okay, and it is a type of axonometry. We have isometry. Inside this CAD software, CATIA or others, you can choose whether to display the 3D object as isometric, diametric, or trimetric. The differences is isometric, the angle is the same. Diametric, the two angle here is same, one is different. Trimetric, all three angles are different. So that's the difference. And here is a glass box approach, or you can see opening the box where we can visualize which is the front view, which is the top view, which is the right side view or the left side view. So when I did when I teach undergraduate student, what I did is on this part we start with the manual using the traditional tools. Okay, this is the section view. If you do it using the manual drawing, using the the mechanical pencil, using the paper, this is a very challenging process. However, if you use the CAD software, it is just a click of a few buttons. So much easier to have this section view. Section view is purposely to see what is on the inside. Okay, you can you can have a cutting plane so that you can see what is going on the inside. Okay, even better, let's say you have multiple parts being combined together, and you want to see the interference, whether interference means some part might overlap or they have some gap. Okay, so the thing is can be seen easily using this section view. Okay, and also the first angle projection or the third angle projection. I don't want to really talk about this one. Then we skip on the one. And this one as well. I will share this slide on this Ultra Blast later on. If I forgot, then please remind me. Okay, hopefully after this session, I will straight away upload to that Ultra Blast. Okay, and then I believe you have also looked into the what we call GDT, okay, geometric dimensioning and tolerance. This is very important for the CAD design because of it will ensure that the part is can be assembled. It is fixed. Okay, it can fix nicely. Because of the reason is, let's say you want to do a cutting process, okay, or you want to print out certain parts using 3D printer. Each machine that you are going to use, okay, each machine have a certain limitation, okay, the accuracy of the machine itself, so that to comply with or to meet that accuracy of the machine, we have to include that into our design. Okay, the machine sometimes have a 5 micron tolerance. For example, like this one, it is 5 micron, 5/1000. So, and it is 10 micron here. So, any machine will have a certain limitation. For example, you buy a like a potato, for example, from a market, okay, and you put on the scale to see the weight of that particular potato. Then it will show in the supermarket, they will have a very good machine, okay, scales, that can give you up to 2 or even 3 decimal points. What happens if you buy it at your nearby shops, or you use your kitchen scale? You will not get that accuracy, right? So that is some form of concept that is I would like to show you when you use a different type of machine to produce certain parts, physical parts. Okay, because each machine have their own specification, have their own precision. So that particular machine precision, you have to take into account in your design. That's why you will have this plus and minus on your drawing. Okay, this is the tolerance. For example, this one. You see that this particular shapes here, or cut out, okay, this one. When you use a certain type of machine, the size will differ from 0.498 up to 0.502. Is about 5 micron. Okay, the plus minus is 5 micron lah. Then to fit this particular slot down here, there is one block that are going down to fit inside this particular slot down here. And this one is the minimum size is 0.495, and the maximum size is 0.497. So you can see that this value here is within this particular range. Okay, in the middle somewhere here. So this part can be can fit into this particular slot easily. Okay, so that's why the tolerance is very important, so that when you have a assembly, it will help you to ensure whether your part can be assembled or not. Okay. Okay, moving on to the 3D printing. As I mentioned earlier, for the traditional manufacturing, where we have a machine like this, CNC, cutter, and many other type of machine, you start with normally you start with a block. Okay, like this one is a block. Then you cut, and then you can see that there are some material is removed. So you have a leftover, a lot of it. Okay. However, on the additive manufacturing, the process is reverse, where here is the animation of that particular project, of the 3D printer, where the machine is actually start from the bottom here. It will create one layer by one layer, and it will go on and on and on up to until it finish lah. Okay, but it will also have leftover. Okay, the leftover is because when you want to perform this printing, during the printing, this, we call it the bed, printing bed, the square shape down here. There is a printing bed. It will be heat up. Okay, there are two methods normally that we use. Either you put some glue on it, on this particular surface, or normally the 3D printer machine will have a function where you can heat up this bed. Normally, the bed is heated up around 60 degrees Celsius. Okay, no worries, 60 degrees Celsius, you can still touch this particular bed. Okay, I've done it many times, 1,000 times. So you can touch it, but don't simply touch it using your hand. Do it slowly, lah. Okay, to get feel of it, the hot. Okay, but please don't try to touch on this part here, because this is the part where the plastic is being heat up and melt the plastic. So the temperature here is a few hundred degrees Celsius. So will burn your skin. I have experienced twice. Okay, so yeah, it will eat your hand, your finger. Okay, next.
Doctor,
Yes.
I just would like to know what are the, let's say, in the production line, what are the main consideration for that company to choose either to go for the 3D printing or CNC machines? Is it any
Okay.
factors?
Yeah, this is the I think we start with this particular slide here. Okay, you'll get the answer when you look into this slide. Okay, for the 3D printing, for now, we are limited in the sense that the material that commonly available out there that we can easily purchase is either ABS or PLA. Either ABS here or PLA. Per roll is about 1 kg. Roll is like this. One roll is 1 kg. 1 kg, and then it is about, the price per roll is about 60 to 150 ringgit. It depends on the quality of the material. Okay, ABS or PLA. Flexible here is you can buy, but not every shop sell this one. So a little bit harder to get it. Okay, and it is a bit pricey. I bought it once last time. I can't remember. I think it's close to 200 ringgit, something like that. And it's about 2 to 3 times much expensive than the ABS or the PLA. Okay, between the ABS and PLA, what is the difference? Because this is the common two option out there. Okay, for ABS, both are plastic. Yeah. Okay, ABS, if you want to design something that require strength, then go for ABS. Okay. If you want to produce something that strength is not really important, but you want that product to be more presentable, nicer to look, okay, more beautiful, so you better choose this PLA. Okay, there are pro and cons between this and this one. If you require strength, then go for ABS. PLA is more on the appearance, less on the strength, and both are plastics. I'm not saying that ABS is twice stronger than PLA or 3 times a bit strength stronger than PLA. No, it's not like that. But generally, ABS is there is no specific paper. Can we mix it? On a typical machine, you can't actually. You cannot do it. Okay, but with the newer version, I'm not sure. The thing is like this. The thing, okay, the newer version of machine, you can install two set of roll like this material. You can put one here, the other one on the side. So the machine can select which one they prefer at certain time. That can be done. But then the basic or the fundamental issue is ABS, the melting temperature of ABS is different compared to PLA. If you set this heated nozzle down here, let's say around 180 degrees to 200 degrees, then it is for ABS. But if you increase the temperature to like 190 or 200 to 220, then it is suitable for PLA. So the melting temperature is different. So that's why I'm saying that I don't think that will work. Okay, it will not work as it is unless you have a very complicated system installed. Then you can. But on the current machine that we have right now, will not work because the temperature, the melting temperature is different. Okay, and when the melting temperature is different, the thing is, if the melting temperature is different, what happens is, since it will produce layer by layer, this layer will not join with this new layer because this one is let's say 180 degrees and the other one is a much higher temperature. It will cause some problems. Okay, ultimate strength value, this one, right? I'm not sure on that, but probably they are referring to very old literature. Okay, if you look in the current literature, current finding, and also I'm telling you that there is also from my experience on using it for more than I think about 5 years for now. That is the experience that I have. ABS is much stronger than PLA if you're comparing apple to apple. Okay, because the material for ABS and PLA, they keep improving, and this particular chart is, this particular table might refer to the last 5 years or 10 years. So I think I also need to update on this one. Thank you for asking that question. Okay, moving on. If you notice, you can also buy or purchase online this 3D printing pen. I'm not saying it is suitable for kids. Okay, because of the part here is very, very hot. Okay, so if you plan to buy it for your kids, make sure they are well trained. Okay, and you have to control them and monitor them. Okay, on this particular slides, this part is not really important actually. These four items here it's important. Here we have a different type of 3D printing. This is a different process. First is a fuse deposition modeling that normally that we have, that I currently use is this one, FDM. And we also have different methods using selective laser sintering, okay, and also stereolithography. Not much different if you look into these two. Okay, let's compare this one, FDM and SLS. Okay, FDM, you have a material on a spool. Okay, material on a spool. So it's like the macam benang lah. Okay, on the spool. And this one is doesn't have a spool, but will have a certain type of plastic, but in the form of apa nak panggil lah, in the form of small particles, okay, like a sand particles.
Is it like a granule, Doc?
Granule is, if for me, if you use the word granule, is a bigger size. Okay, for me, granule, granule. Okay, if you have a sugar, for me, granule represent the sugar size. You know, the typical sugar size, the particles, right? For me, that is the size of granules. But this one is much smaller than that. Is macam habuk, like a dust, okay, powder, okay, very small particles. And what happened is there is a laser. Okay, the particles is layer. It is what do you call it? It is, I don't know what to call that particular process. Okay, let's say the particle here is pushed upwards, and one mechanism, roller, will lay down all these particles on this part here, and then one layer of dust, and that particular dust will be heat up, okay, with a laser. Laser will heat up that area, and that area will melt and connected to the previous layer. So that process will be repeated layer by layer. So instead of using material like this one, you put the material, they use some sort of powder lah. Okay, type of FDM fuse deposition machine for this one. I'm not going to discuss detail on this one because this machine is super expensive. I think we have one that belong to the mechanical department, if I'm not mistaken. And last time it cost millions. Okay, just one machine, 1 million or something like that. So it is very, very expensive. And on this slide here, we have FDM 3D printer, and here the things is like to highlight that there are two type of mechanism that is available out there. Is either using the Cartesian or using this delta, where using the Cartesian there is a motor down here and on this side and also up here. Motor here will control this motion like so. Motor on this side will control like so. And another motor up here will control up and down of this particular heated bed. Heated bed will be located here. Okay. For the delta machine, the heated bed, the heated nozzle. This down here is the heated bed. Up here is the heated nozzle where the material will go down. Okay. And on this one, on this machine, they will use some sort of actuator, okay, to control the motion of this nozzle, heated nozzle. Okay. Generally, people prefer this one, this machine, Cartesian. Okay. But if let's say you want to produce to print out a vase for your flower, right? Vase or labu sayung, for example. Then this machine will do much better compared to this one, this Cartesian, because this machine is superior in producing a product which is have a round shapes. Okay, so that is the general differences lah. Okay, this is the basic filament that we have. It is a roll. One roll is 1 kg, and then it is the yarn. Don't know what to call this one. Yarn will be fed through this feeder, and inside this feeder there is a small motor that will push or pull this particular yarn, push upwards lah. If we refer to this particular image, it will push upwards away from the spool, and then going here, and then we'll push the yarn into this printing head, and inside the printing head we have the heated nozzle. Okay, heated nozzle. Later on, if after the PKP or MCO ended, I can bring you guys to the lab and you can see physically the machine. Okay, and we can let it run, and you can feel it on how to, and you can also learn on how to use it on your own. And then this is the build plate. You can print one object or 2 or 3 or 4. It depends on the size of the bed that you have, and also type of product that you are printing. Okay, how it works? Of course, start with ideas. Start with if I would like to link with our course, it may start with the requirement analysis. Okay, start with the requirement analysis. You do the survey, Pareto, and then what else? QFD. You get all the information, then proceed with the morph matrix, and after the morph matrix, you analyze your concept using uh, view matrix, and also using the topsys to get the final specification or the final concept, design concept that you want to produce. Then after, then only then you start to do the CAD design. Okay. So what we have learned is this one on this part. And then, okay, after that, we do the CAD design. And after the CAD design completed, then you will use the slicer software, or normally people also call it as a 3D printer software, okay, to generate the G code. Don't forget, when you do the CAD drawing using CATIA or SolidWorks or any other CAD software, make sure you save that particular file with .stl. Okay, .stl. Then you save as .stl. Then you can transfer that particular file into this software, slicer software or 3D printer software. And in the 3D printer software, you need to specify the orientation of the printed object, the scale of that particular object, what else, and some other setups that require. Okay, then when that is completed and you generate the G code is transferred to your micro SD card. I have one here with me right now. This one. Okay. I'm not sure whether the camera can just a micro SD card. Normally we use a micro SD card, and then you insert the micro SD card to this control panel of the 3D printer. Then you can start the 3D printing process. And it will take a while, depend on the dimension, accuracy, and many other things, the speed of the printing and the heating process. Then all those parameters will determine uh, the time for the printer to complete the printing. Okay, and finally you will have your product. If it is a frog, then you get a frog. Okay, it is a more specific process that I have explained just now. Okay, another way on how to visualize it, you have the material on the spool. Normally this one is 1 kg, and it will go through this feed, and this feeder here will push or pull this filament and push it to this heated extrusion head or print, or we also call it as a heated nozzle, because the shape is like a nozzle. And then it will the filament will melt, okay, and it will put on this particular platform down here. This is the heated bed, layer by layer. Okay, and 3D printing software. Okay, just like the CAD software, there are many type of 3D printing software. I list up here, and it depends on who you are, whether just a beginner or advanced user, and also your operating system lah, OS. Okay, 3D printer OS. Here, it is a cloud-based platform that integrates all the different components essential to 3D printing. Okay, it is a cloud-based platform. And then this one is called Craftware, developed in-house by 3D printer manufacturer. Normally, certain, okay, this one I would like to highlight. Certain printer, you can use any apps. Okay, most of the free apps that you can download. Certain printer, but certain printer, you can only use their dedicated software. Okay, it will not work with other software. Okay, and another type of printer, they only have they have their dedicated software as well as dedicated printing material. You cannot change that one. Okay, so for me personally, you better buy 3D printer which is accept any software and any type of material. So you have a freedom. Otherwise, you will have a problem to get the material and to update the firmware. Okay? And this one is a maker board print. This one is dedicated to the software is dedicated to maker board line of 3D printers. So I'm not really happy with this type of machine. Okay, and then CAD 2-in-1. It allows you to design your own model and set for 3D print. I would say this one is good for your kids at home. If you plan to buy one small 3D printing machine. A good one, actually, a good 3D printing machine that you can buy right now is called Ender 3D, Ender 3D Pro or Ender 3D, and it costs just under 1,000 ringgit lah. Okay, you can buy. That one is a pretty good one. I have one in our lab, aerodynamic lab. Okay, and this is the software that I'm using right now, Simplify 3D. This is not free. You have to purchase this particular software. With me right now, I have 2 licenses with me, and it cost me around 500 to 1,000 ringgit. I can't really remember. Okay, but it cost me less than 1,000. It is a lifetime license, perpetual license. Okay, no need to renew. And this particular software is you can install it on. It will work very well with many type of 3D printers, which are not the dedicated type of 3D printers. And with that particular software, Simplify 3D, and other software as well, okay, not all, some of it, you can simulate this printing process. Okay, you can simulate the printing process so that you can identify issues in advance before you start with the actual printing process. So it is very useful. Okay, now this is the thing that if you recall just now when I talk about the traditional methods, traditional method on producing parts, where you start with a block of metal, for example, then you send to the machine to do the cutting, right? Then you will have a leftover, okay? And there is a lot of leftover. For the 3D printing, you will still have some leftover, but it is very minimum, okay, compared to the traditional method. It is not 100% clean or totally zero waste. No, with 3D printer, you still have some waste. Because of, the reason is, when you do printing something, let's say an object that is very tall, okay, very tall, very thin and tall, okay, then during the printing process, the bed will move sideways, okay, the bed will move. Can we do a face mask? Actually, during the PKP, UPM have produced, I think, more than 2,000, not face mask, what you call it, a face shield, that one, the bracket up here. Two of my master students, I send them to do the printing at the faculty to support our frontliners lah. And they are using two of my 3D printers at that time. And I'm not allowed to go to the UPM, but since my student is there, so I asked them to help the faculty, and I think they produce around 2,000 over 2,000 units of face shield. Okay, not with two 3D printer, but they have more than 10 3D printer at that time. So yeah, we that is our job, like during the early PKP or MCO. Okay, then if you look into this cylinder block, okay, this is for the V6 engine, okay, and here you can see there is a different color of material, right? This one, and also this one. Okay, the color is not yellow or orange like this. It is much darker color. Okay, this material, we call it as a support structure. Okay, support structure is needed when there is a overhang. You know overhang? When you want to print something like this, straight up, you don't need a support structure. But when you printing something that is slanting like this and at angle, you need something to support. Otherwise, it will go down. Okay, to support. So this particular support structure here, after the printing process completed, you can remove it. Okay, and when you remove this support structure, this will be your leftover. Okay, that's why I tell you that 3D printing also have a leftover, because we need support structure. It depends on your design actually. Okay, some design doesn't require any support structure, but some design definitely you need a support structure. And also, if you want to print out something that is very tall, thin and tall, you might need some, we call it here is a skirting. Skirting is outer layer here, the purple color here, to this one as well, to actually give some what do you call it? Okay, first, I forgot to mention about the heated bed. Okay, the bed is heated up to 60 degrees Celsius because when the material, the melted material uh, from the heated nozzle drop on this bed, what happens is there is a sudden temperature changes. Okay, the heated material, let's say about 200 degrees, and the bed is at room temperature, what happens is the material will have a very big gap in terms of temperature. Okay, from 200 degrees Celsius to let's say the printed bed is around, the room temperature is around 20 degrees Celsius. So what happens is it will not stick to the surface. Okay, the material will not stick onto the surface. So that's why the bed is heat up to 50 or 60 degrees Celsius to reduce or to minimize the gap between 200 degrees Celsius to around 60 degrees Celsius, so that the material will have can stick quite well, quite good on the surface. Okay, and if you have a very tall object, you might need a lot of extra surface, so that your material, your product will not fall off. Okay, so that's why you have this kind of what we call skirting, outer layer here, to let your parts or your product adhere to this particular surface. Okay, and this is you can print multiple parts at one go, but for beginners, I think you have to do it one by one lah. Okay, don't do this process. Probably after at least 6 months or 1 year after familiar on using a 3D printer, then you can start thinking of doing this sort of project like this, printing multiple parts at one go, because you need a lot of experience. Okay, experience on using that particular machine, because every machine will have different characteristics, so you have to learn them first before start thinking of doing something like this. Okay, variable printing setting, I don't want to go deep into this one. Okay, this one is very important. You might think of that the internal, if you print like just now we saw a frog, right? You might think that inside the frog is either hollow, okay? Inside the frog is nothing inside the frog, or you might also think that inside the frog is full with material. But the thing is, you can control that thing, whether it is hollow or whether it is solid inside this the body of the frog, where here there are options. You can put 10%, 15%, 20%, 50%, 70, or any percentage of material inside that object, or in this case, just now we have a frog, right? So what we call it the infill density, the density of the material inside the object, you can control, okay, using the slicer software or 3D printer software. There is an option for you to control that density, and also the shapes, the inner shapes. Okay, you can do it like this one, like honeycomb, linear, rectilinear, and cross hatching like this, and many other shapes. If you're not mistaken, it's around 5 or 6 different shapes. Okay, so you can control the density, and also you can control the shapes inside your product. So different shapes, different density will eventually will improve the strength of that particular product. So that's why I told you that you need experience, a lot of experience on using the 3D printer. Then you will appreciate on how to select different type of inner shapes, inner layer. Okay. And last but not least is typical 3D printer, the cheap version. It is a very exposed, like this one. So if you want to put it at your home, okay, keep it away from your kids, because there is a moving platform here, moving object, and also very high temperature nozzle on this part here. And also the bed is about 60 degrees. So you need to ensure the safety of this particular machine, because when you produce something, small parts, it will take like 1 hour, 2 hours to produce. But complex geometry, there is a lot of curved shapes and a bigger object. It may require even up to 1 or 2 days, okay, non-stop process. Last time I tried up until 2.5 days to complete. And sometimes the printer cannot do it. After 2 days, then it will become haywire. So yeah, there is an error. So try to design something that can be produced within reasonable time. Okay, less than 6 hours, I would say, should be a good time lah. Okay, and this is some printing fail that I have experienced myself. Like this one, the material didn't stick to the heated bed. Okay, the material is not stick on the heated bed, and then it will go haywire like this. So yeah, and this one, what happened is the materials stick on this component. It didn't stick on this heated bed, but stick on this heated nozzle. So you will have a clog right like this one. I experienced like this type of problems I think about 4 to 5 times over the last 2 years. Okay, and it requires a very uh, challenging process to remove all this, because you need to reheat the nozzle. At the same time, you have to slowly remove this chunk of material. And it's good if you have a proper tools to remove this material, because when you remove it, it is quite hot, over 100 degrees Celsius. Okay, thank you. And this is my 3D printer at fabrication lab that need to be repaired, okay, because I have a problem with the power supply. Okay, thank you for your attention, and that's all for the 3D printing that I can share with you. I hope you will get something, and hopefully you can get the experience on using the machine. Okay.
Doctor,
That's all. Yes.
can you give me a rough price for the 3D printing? I mean, if I am to give
Okay.
a job to someone else.
The job to someone else.
Yeah, like if I send something to 3D print, maybe a shop, and then yeah, how much they will charge maybe.
Okay.
Let's say for a 50 to 50 mm by 50 mm, and the thickness is like 5 mm.
Okay, normally there are two parameters that normally people refer when they want to charge how much, okay, the cost for them to produce that particular part. One is how much material that they are going to use. Okay, that's one. Okay, because the material, this one, you buy roll by roll. One roll is about 1 kg, and the price is around 100 ringgit lah. It depends on the material. Then, okay, that's one. The other one is how long the process to produce that particular printing. So that is the common two parameters that people will determine the price for the printing. And with me right now, I don't have any clue on the price, on the charges, but I do know that that is the parameter for them to have a basis on how much to charge on that particular job. Okay.
Is there any way we can estimate? I mean, like how much of this?
50
how much
mm.
of the material would be there?
50 mm by 50 mm, and the thickness is 5 mm.
Yeah, maybe something like a sheet.
And that is just like a box shape or what?
Yeah, something like a flat, some kind of plate.
Flat surface.
Yeah, yeah.
I would say in the order of 100 to 200. I think over less than 100, I would say. Okay. Because of they also one more thing, the expertise on how to do the setting for the printing. Because if you ask a beginner to print out your product you will get a beginner quality lah. Okay, so to do the setting is not really, it's not that easy, because of there are, to set up this bed here, you have to manually tighten these 4 bolts on each corner to level the bed, and to ensure the heating bed is you know, uniform, and so on lah. So if you are considering the expertise, that's why I'm telling you that yeah, there are 2 components. One is the how much material that needed. The other one is the how long the printing process. However, the setup for that particular printing process is depend on the complexity of that particular parts as well. So to to look that process as a whole, I think it should be less than 100 ringgit lah, based on what you have mentioned just now. I think
Is there any way we can estimate how much material would be required for
how much
the
material?
specific piece from the drawings?
Okay.
Yeah, from the CAD drawing.
Okay, from the CAD drawing, what you can do is, if you are using SolidWorks, for example, there is an option where you can define the density of the material. Okay.
Yeah.
Yeah, you can put the density of the material. If let's say you are using the PLA, and you can Google what's the density of the PLA, then you put it there, and straight away the SolidWorks will give you a good estimate on the weight of that particular parts.
All right.
Okay. So
thank you.
yeah, weight is just sorry, not weight. The mass is just the density multiplied by the volume, right? So then you can get estimate from there. Okay. Any other question?
Doctor, how about the surface finish? Is it going to be the same for all materials, or it depends on certain parameters?
Okay. The surface finish, if you compare with between ABS and PLA, PLA will appear much better. Okay. ABS not so nice to see. You can get a similar result like PLA, but require additional process. You have to put it in a closed container together with acetone or etc. and a lot of process lah. For PLA, it is a much better appearance, but you may need to control the speed of the printing process, and the size of the layer. Okay, the size of the layer, and what else? How much outer layer that you are going to put, and there are, I think, about 10 to 20 settings on that software that you have to play around to get a better final product.
Okay, so really needs an experience to do that, yeah, doctor?
Yes. And I learned in a hard way last time. So it took me like a year, almost a year, to really understand on how to use that particular machine.
Thank you
So,
for the explanation, Doctor.
yeah. Any other question? Martin, yeah, please.
Hello, Prof.
Yes.
I see some news say 3-point technology can be used to print human organs, like a heart,
Yes.
arm, or like use our cell.
Okay. In UPM, I think there are a team together with other universities lah. They are working on printing certain parts for medical. Okay, for the medical, as well as to look into suitable material that can be produced, like the implant or the joint to put in your body. So there are, it is still at the research stage. I don't think, the currently there are no, I would say, usage on human.
So in the future, we don't need to
Yes.
donate our organs, just print it.
Yeah, the research is still going on. I believe at some point later on, some parts can be printed out and can replace certain body parts. I'm not a medical expert, so I can't really get.
All right.
anything.
Thanks,
Yeah.
Prof.
Yeah. But there are research on that. Yeah. Sure.
Thanks.
Yeah. Any other question? Okay. If no question, we will end our session. Your paper still with me right now. I already printed it out so that much easier for me to do the marking. And hopefully by next week, I will personally tell you your performance lah, in general. I don't think I will give you detailed marks. Okay, I will not reveal that, but I will discuss or tell you, hopefully one by one, on what need to be improved. Okay, I think that's all for tonight. Thank you for your time, and hopefully next week we will have another session that
Thank you,
we,
Prof.
yeah, I think we have another 1 or 2 sessions because I have 2 more slides to go, and if I combine those slides, then we only have 1 session. If I split that one or I maintain like as usual, then we'll have another 2 sessions. Okay, thank you. Good night.
Good night,
Thanks,
Prof.
Prof.
Thank you,
Good
Doctor.
night.
Thank you.